Hello, my name is Jesusa Legaspi, Research Entomologist for the USDA Agricultural Research Service, Center for Medical, Agricultural, and Veterinary Entomology. I'm also a Courtesy Associate Professor based at Florida A&M University in Tallahassee, Florida. I would like to talk about my research on a dual strategy of the combined use of push-pull technology and companion planting to mitigate insect pest damage. Sweet potato whitefly, thrips, and aphids are major insect pests in vegetable crops in North Florida. The use of push-pull technology, or PPP, and companion planting are cultural and conservation biocontrol methods which may mitigate damage by these major insect pests. We are developing sustainable and environmentally friendly technologies to manage these pest populations that reduce dependence on chemical insecticides by deploying plants that release volatiles that naturally repel the pests, and this is the push factor, or attract them to trap plants or products, which is the pull factor, and away from the commercial crops. In collaboration with Dr. Alejandro Volquez, Extension Crop Specialist and Assistant Director of the Florida A&M University Research and Extension Center at Quincy, Florida, we evaluated the push-pull technology in controlling insect pests in tomatoes in a screen structure. In summer 2019, the tomato varieties that were planted were Heat Master, Beef Master, Super Fantastic, Better Boy, Goliath, Big Boy, Florida 47, and SV7631TD. We tested the push component of the PPP using potted repellent plants of citronella, society garlic, and lemongrass. These plants are readily available in commercial nurseries and will grow back after the cold weather passes. Groups of these plants were interspersed within rows of the tomato crop in 4 different areas in this greenhouse. The pull component involved the use of green leaf volatiles such as leaf acetate to attract whiteflies away from the tomato crop, after which they could be trapped using sticky traps. To complement the PPP, we used companion plants such as marigold and basil, where the flowers serve as a food source in the form of nectar and pollen for the beneficial or the good bugs that in turn may reduce the numbers of insect pests. The African basil variety that we used is a perennial, so they can be used throughout the year. In our study, we found that the numbers of sweet potato whiteflies, aphids, and thrips were relatively low throughout the cropping season. Due to the low numbers of whiteflies, the green leaf volatile was not feasible to test. The good bugs were mainly the minute pirate bug and whitefly parasites such as the Encarsia and Eretmoceras species. The yield from the tomato crop was found to be comparable to the yield from current standard commercial practice. Although preliminary results from our laboratory and greenhouse tests indicated that the green leaf volatile leaf acetate may be promising for use as the pull factor, more studies on different concentrations will need to be conducted in high tunnels. In general, the dual strategy using PPT combined with the use of companion planting may be part of an ecologically based pest management program to control major insect pests of organic vegetables in enclosed structures. For smallholder growers, this is a low-cost, sustainable, and environmentally friendly management tool that can be included in an arsenal of pest management options against insect pests in high tunnels in the southeastern U.S.